Hello, everyone. Welcome to this event. This is awesome. Thank you, all of you, for being here. Some months ago, we actually launched this idea of doing Kotlin everywhere, and it was about trying to get two ideas across. First of all, that we want Kotlin all over the globe, and the second one was that Kotlin can be used everywhere, whether it's mobile, front-end, back-end, etc. So together with Google, we started this initiative, and we are now having over 140, if not more, events worldwide run by the community. We wanted to make a special event here in India. So, we had a lot of requests of, are you going to ever do a Kotlin Conf in India? Not yet, but we did the next best thing, right? So you've got a full day of Kotlin everywhere, multiple tracks, multiple sessions, etc. And in this talk, I'm going to give you a brief outline of where we started, where we are today, show you a little bit all of the different things that you can do in Kotlin, and then you can then go to the specific sessions and dive deeper into any of these topics. So we started in 2010, and back then we were creating a language that we needed to be interoperable with the work that we were doing, and most of the work that we do is on the desktop and server-side applications. If you know of our IDEs, that's what we do. So we needed something that was interoperable, because we couldn't essentially just say, you know what, we're going to close shop for like 6-7 years and rewrite everything in some other language. We needed to be able to interop with what was existing there. And we needed a language that was available for server-side, desktop, and mobile. That's a lie. We didn't actually have mobile. We didn't want a language for mobile. Well, not wanting is overstatement. We didn't plan on having a language for mobile. Like, we don't do mobile development, so we're like, man, Android, what's that? No. And how many Android developers here, by the way? Hey, awesome. Right, Hadi. Okay, never mind. So, and then someone posted a question on the forums. They're like, does it work with Android? We're like, we don't know. Go try it out. And they tried it out, and it failed. But it was a really easy thing to fix, and we fixed it. And then, the rest is history. Now, it's the preferred language for mobile development. In 2012, we thought, we're targeting the JVM, we're targeting Android, why don't we target JavaScript as well? Because there's a lot of people out there that want to do web development, back-end development, using, the node module system, all of these things. Why not create a target platform be JavaScript? Also, every other language on earth was doing it. We couldn't say, well, we're not doing it. So we decided to do that as well. But again, we followed the same idea in that this has to be interoperable. So we don't want people to have to reinvent the system. We want them to get up and running just like you do on the JVM and on Android. So we made the JavaScript side completely interoperable with everything that exists on JavaScript. That means if you're using modules, common modules, you could do common JS, you could use AMD, anything that you wanted, you would be able to use. And develop web applications, meaning you could do stuff on the front end and, of course, on the back end. We also did something else that year, which was Kotlin scripting. And the idea behind Kotlin scripting is that I could actually create small little scripts that I could host either in an application or just develop myself. And this has many usages. I could do build scripts, I could do test scripts, command line utilities, routing scripts. If any of you have heard of Ktor, there's actually a talk, I'm doing one as well today on Ktor, which is awesome client and server-side technology we have in Kotlin. Type-safe configurations. I mean, our product continuous integration tool, which is TeamCity, now all of the configuration is written in Kotlin, in a DSL. REPL, and even data science. We're starting to see an increase of people adopt Kotlin for data science. And that goes hand in hand with this REPL, with this interactive console of having tests that you do on data. In 2017, we decided to go one step further and create Kotlin Native. And that basically enabled us to target a whole bunch of more platforms, namely iOS, macOS, Android, 4 squares and a penguin. And I still don't know if that's Walmart or WebAssembly, one of the two. So this gives now people the ability to target any kind of platform they want, even without a virtual machine. But again, leveraging the existing ecosystem. So interoperable with C, interoperable with Objective-C, interoperable with Swift. Types of applications: mobile, macOS, mobile, iOS, macOS, desktop, system, embedded. All of these things are now available, even Raspberry Pi. I mean, you could even create Kotlin applications with a JVM on the Raspberry Pi. Now you could do it with native. So native, the way that we do it, it uses this concept of LLVM. And how many of you here have heard of LLVM? Okay, so it's not a virtual machine, despite saying VM. It's an open source tool set that allows you to target specific platforms. But we needed to provide the same kind of guarantee, because essentially the idea here is that when you're using Kotlin as a language, the surface area is going to be exactly the same no matter what target platform. So you don't have restrictions that says, oh, if I'm targeting iOS, I don't have this language feature. Everything is exactly the same. And that means when it comes to memory management, exceptions, etc., there are things that we want to provide that give you the same experience. We also provide you with the standard libraries and some multi-platform libraries, which I'll get into. And then there are specific libraries for specific platforms where we give some aid as well. Then the way that LLVM works is essentially that you take some source code, Kotlin source code, and the front end, that's what the JetBrains team works on. That's what the Kotlin team works on. It's the compiler. And then that emits intermediate representation that is, we then use LLVM to target different platforms. So any platform that LLVM targets, essentially we target as well. Now this IR is an important thing as well. When we first started with Kotlin, we were just doing bytecode. Then when we did JavaScript, we started to transpile to JavaScript. Then we did native, we started to do this IR thing. Now we're consolidating all that. For the past 1.5 years, we've been working on consolidating a single intermediate representation. So whether you're doing Kotlin native, Kotlin JavaScript, or Kotlin JVM, it all goes down to one IR, and then from there, it goes to the different platforms. This will make it better for you in terms of performance, easier for us to maintain, and provide new features going forward. So that's work that we've been working on. In terms of memory management, on the Kotlin native side, now if you're generally working with Kotlin in itself, it's absolutely fine, but when you're interoping with other systems, you need to worry a little bit about memory. So we have ARC, which is automatic reference counting, which is similar to iOS. And we also have the cycle collector. Now, the cycle collector in many languages is supported by weak reference. And the idea is that if I have a pointer A and that points to B and a pointer B that points to A, this causes a cycle and the ARC can't intervene and collect it. So a lot of languages use weak references. We have weak references, but we also detect cycles. And again, as I said, when you're working with pure Kotlin, you generally don't worry about memory. It's when you're starting to do some interop with C, etc. But we're also trying to do a new thing, which is the idea that shared and mutable data are not good. So we have a strict model where the compiler essentially is going to detect that you don't want to be able to do this. And this is something that we've been working on, and we'll see how it actually unfolds moving forward. But targeting multiple platforms needs more. You can't just say, well, okay, now I've got a single language that I can target a whole bunch of different platforms. But if I do that, I need to be able to do other things such as share code. Because I don't want to repeat the same thing over and over again on all these platforms. You need to be able to share code. So the idea here with multi-platform, which is what we're doing with Kotlin, is that I have some common code, and then I can target all of these different platforms. Okay? Now, those of you that are familiar with or do mobile development, and you've done something for Android, and you may have done something for iOS, for instance, right now you are basically choosing one of two options. You either target each platform natively, or you're going with some existing solutions such as Xamarin, such as Flutter, such as Cordova, all of these different things, or React Native. So everything that they do, we do differently, right? So we don't have a common UI, a common layer, anything that you just program to us and we port it onto different applications. We say the vast majority of your application is your business logic, it's your data validation logic, it's even logging, HTTP, all of this stuff. This could be common code that you can abstract away, and then anything that is specific to that platform, you use the native SDKs and what is available on that platform, the APIs, to interact with it. So if you're doing iOS, you would use the Swift components. If you're doing Android, you would use the Android components. So you delegate as much as you can to the common code, abstract as much as you can to the common code, and then delegate the little bits to each platform. But this also brings another issue with it, which is when you have common Kotlin code, there may be a lot of things that are common, but then there's a tiny little specific thing that may vary based on the platform. And then that leads you to a situation of like, well, can I now make this common or not? Or I have to do it a different way. That's where we introduce the concept of expect and actual, where essentially think of it as interfaces and classes, the implementation of those interfaces, with compile time checking. And when we see some examples, I'll show you how this works. So this now allows me to have common code with specific code on each platform that may behave slightly differently, but yet reference it from the common code. And in addition to that, we're working on a series of multi-platform libraries. So these are basically libraries that are going to be available to you on any platform that you use Kotlin, including HTTP, which is Ktor. Ktor actually now is not only a server-side tool framework, but it's client-side libraries as well. So Ktor allows you to connect to HTTP to JavaScript, native, and JVM. The same we're doing with serialization, the same we're doing with coroutines, settings, loggings, etc. And then there's other people in the community, there's other companies. Some of you may have heard of. Square recently announced that they're doing a whole bunch of work around this to move towards the multi-platform solution. Okay, so with that, let's switch over and let's show you some code. That was weird. Okay. So, I'll start with, how many JavaScript developers here? I'll start for the 6 people. No, I'm joking. This is for everybody. Everybody in this life knows a JavaScript developer. So even if you don't do JavaScript, you go and tell your JavaScript friends, say, look what you can do now. So this is JavaScript. Well, no, it's not. This is Kotlin. Okay? The only similarity it's got with JavaScript is that it's all in a single file. Not that you would, I didn't mean that you would develop JavaScript applications all in a single file, although the majority of them probably do. Or at least they deploy it in a single file. So this is essentially a data class. I've got some functions that is basically doing a whole bunch of things in Kotlin. Some of these are, for example, DOM interaction. You can see that I have a document. And if I click doc, you see that I get completion. This is statically typed. So I can navigate to this BG color. It's there, it's statically typed. So I can do DOM interactions. I can do things like inlining JavaScript. So the idea here being that from Kotlin, you can write Kotlin code that targets JavaScript, talk to Kotlin code from JavaScript, and from JavaScript call Kotlin, and from Kotlin call JavaScript. So here, for instance, this would be the equivalent of doing an eval in JavaScript itself. Then I have this function over here, which is alert. And what alert is, it's got a little modifier in front which says external. So what this means is that it's available at runtime. I'm going to be able to call this function. I don't need to define the actual function itself. And you can see that I am using this function down here in alert from my Kotlin code. Now, this is a single file, and it's got a main entry point. Generally, when you're writing Kotlin applications in JavaScript, every file doesn't have an entry point. I just have this main function to show you how this actually works. And I'm calling a whole bunch of different things. So when you compile this, what it's going to do is going to create 2 files for you. One of them is called Kotlin.js. And this file is essentially similar to jQuery. You never open it. Okay? It's just this thing that's there, and it's awesome, but you don't ever have to look at it. This contains everything that you need for the interop, and it contains everything that is part of the standard library for Kotlin. So you get all of that on the server side. The file that you generally look at is the output of your application, which in this case is sample.js. And you can see it's pretty short, and it's pretty readable. So you can put that through your obfuscators, through your minimizers, through your simplifiers, through your whatever revisers you want, and convert that into a mumbo jumbo. But we generate pretty much readable code in JavaScript so you can see it. And all of it is compatible with the module system that you use, whether it's CommonJS or AMD or what have you. And then how do I use this? Well, I have a file here which is called first.html, and this file essentially loads the two scripts. The first one is the Kotlin.js, and the second one is the sample.js. So all I need to do is essentially run this. It will open up the browser, execute everything as you saw, submit. All of the things that I put in the DOM, in the main, are all available there, and you can see that it's essentially the same file there. Right? So this is nice, and it's like, okay, this is cool. You can do basic things in JavaScript. But what else can we do? I want to show you the level of production that this is ready. So let's switch over to the terminal. And how many of you have heard of React? Okay, a few more. So this is npx React, create React Kotlin app, my app. So it's essentially the same as create React app, except it's all in Kotlin. And this is going to generate a Kotlin application for you using all Kotlin source code, and then you can start it up just like you would a standard template for React. Obviously here, it depends a little bit on my internet connection and the speed. So can you all please get off of Twitter for a second? So if we look at this, see, it's created a folder called my app, and then we can do source, app, and you see that I have basically Kotlin files. Now this is pure Kotlin code. And that div and the P and P that looks like JSX, it's not JSX, it's pure Kotlin code. It's Kotlin X HTML. It's the cross-platform HTML library that we provide. And if I want to run this, I just do npm start like you would do a normal application, and that will launch my browser and show me the application running. Now we use the same system as those, wait for it, wait for it, wait for it, oh. You don't have to clap for that, I just executed a script. Someone else did all the work. But the point is that we don't do anything special. We leverage the existing ecosystem. So if you're familiar with definitely typed is basically the ability to create definition files for TypeScript for many of the frameworks. We leverage that. We have a TypeScript to Kotlin converter, so the community contributions to definitely typed to TypeScript immediately are available also for Kotlin. And this is way production ready. In fact, there's a new product that we haven't launched yet at JetBrains, which is web heavy. I don't mean it's heavyweight, I mean it's got a lot of web functionality, and it's using Kotlin JavaScript. Okay, so let's move on to something else. This is a brief overview of what you can do with Kotlin JavaScript. Let's now switch over to the console, where I'm going to show you Kotlin Native. I'm going to show you two things. First of all, Kotlin Native. Second of all, my Vim capabilities. Fun main, print line, hello, I don't know how to exit this damn Vim. Okay, no? What do you mean no? Go away. Right, so now what I'll do is tools, Kotlin Native, bin, Kotlin Native compiler, and then a.kt, right? And what this is doing is compiling this application to the native platform, which in my case is macOS. And you have the option to do cross-compilation. Now, Kotlin Native is in beta. One of the things that we're going to be working on is improving the performance of the compiler. This will make it much faster for you to compile application. It also makes it easier for me to do demos because I don't have to talk rubbish until this thing is essentially compiling. And this gives me program.kexy. And now what is this program.kexy down here, you see, right? That this is what happens when developers try and do naming. Because first of all, exe only makes sense on the Windows platform, not on macOS. Second of all, prefixing something with a K was funny the first 380 times. It's no longer funny or amusing. But nonetheless, they do say naming is hard. So what I'm going to do now is make this Mac-friendly, which essentially means get rid of the extension. That's one thing I like about Mac and Linux. You don't know if something's executable if it doesn't have colors, and you just keep running it, because no one actually looks at the executable permissions on the left, right? They're like, oh, this doesn't work, oh, that one works. So program, there you go. How fast was that, right? Immediate. Also, this screen is really, really nice. I should get one of these for my house. Anyway, so next. Now, similar to JavaScript, what I want to do is leverage the existing ecosystem. So here's an example of libcurl. Anyone heard of libcurl? It's essentially your default library in C to do some HTTP. So if you go to the browser and we say libcurl HTTP sample, and we come down to libcurl source code, and we scroll down to HTTPS, we can see that this is the source code to how to make an HTTP request in C. And if you look at it, it's got a bunch of things like curl easy set up, curl easy cleanup, etc. But essentially, this code is verbatim this code, except this is in Kotlin, and the other one is in C. Now, how many of you have ever taken Java code and copied it and pasted it inside IntelliJ or Android Studio, and it's converted it to Kotlin code? Okay. So today, I'm really happy to announce that you can take C code, paste it into IntelliJ, and it still generates C code. One day, though, it will, hopefully one day it will generate Kotlin. One day it'll generate Kotlin code. Okay, so what is this exactly? Essentially, I'm just reading the command line arguments, calling easy init, calling set up, basically verbatim as libcurl tells me to do, and then I'm compiling this application and running it. But where does this come from? Where is this curl easy init? So if we navigate to it, we can see that it's a header extension for, well, it's actually a function for calling the corresponding library in C. And how is this generated? So for Kotlin Native right now, we're using Gradle. And you can see here that I have macOS target, and then I have compilations, and then I have this block here which is called C Interop. And what C Interop is essentially a tool that we provide that generates headers in Kotlin for C libraries. So in this case, I have a folder, native interop, C Interop, libcurl.def, and this is the same name that I've given to this segment, and I can additionally add like compiler options or where I want the package name header to contain, what package I want it to be part of, etc. And this is part of the build process. So it will execute this, generate this for me, and now I can reference this in my application. So if we build this, just to show you the libcurl as well before that, you can see that essentially it's just a very small file with a few options which tell me generate header files for me for this specific library. So in my case, it's curl. Now you can do dynamic or static binding, etc. as well, but normally like libcurl is something that's on most systems, so I'm not even bundling any binary, I'm just using the libcurl that is on the system. So if we were to build this, what this does is essentially give me also an executable. So let's switch over to the actual folder. So native build, Native. Build, bin, macOS, release executable, and there's my executable right there, right? And now I would do something like HTTPS, JetBrains.com, and that would go out and fetch HTTPS and return the result for me as HTML. And all of this is delegated to libcurl. Now, if you've ever done any kind of C, or even if you haven't, any kind of SDK, any kind of API that you could potentially think of is always going to be available first on C and then on any other platform. That's just the way it works. Okay? There's a slight exaggeration there, but pretty much you know that anything is essentially available in C. So this gives us the ability to create Kotlin native applications and interop. And I've shown you examples today of just like interoping with a libcurl library. Today there are actual sessions which are going to show you how to do this and create iOS applications and Android applications and leverage the whole common code. So we've got sessions prepared for you around this topic. What else do we have? Let's take a look at multi-platform. So one thing that I mentioned is that as you start to do these types of application, you want to be able to extract that code. You want to be able to have that common code. So if you come to IntelliJ and do a new project, you can see that it has a bunch of functionality here, which is namely a wizard, and then if I click on Kotlin, I can select a bunch of different types of applications. So if I were to select, for example, a multi-platform library, Gradle, it would generate for me a project which is targeting multiple platforms, and we'll see what that generates. I could do mobile, Android, iOS, and that would do it for mobile, Android, and iOS. So you have this concept of a multi-platform project, meaning a project that understands that this code is going to target multiple platforms. Now, a word of warning, well, heads up, that we're going to change this wizard somewhat, because otherwise we're going to have a combinatorial explosion of options here. So this wizard is now being a little bit redesigned to make it much easier for you to select what build tool you want to use, what target platforms you want to target, do you want to include some multi-platform libraries, and all of those things. Okay? So if you generate the default one, what this is going to do is create for you a full project that I've got open here, which is MPP, and essentially, this randomly works and doesn't. So essentially, let's scroll down here. There you go. On the left-hand side, you can see that I have a bunch of modules. So I have the common, I have JS, I have JVM, and I have macOS. They're all different modules that I have available, and that's what the wizard has generated for me. It's also said, you know what, you should be testing your code, so I'll generate the test ones as well. But just like any other project, you can easily delete all the tests if you want. I didn't say you do. I said you could. Back in my days, when I first started programming, you knew it was working because you shipped it and no one would call you. So, yeah, no, don't clap. That wasn't a good thing. I'm not proud of that. Anyway, so here what we have is basically a function which is hello string, hello from platform.name. What is platform.name? Well, right now it's something. But that code is nothing peculiar. It's standard Kotlin code. I've just got a function that is returning a string that is referencing an object. Now let's go ahead and click on this object, and we see that we have the declaration of your standard object. The only difference is that it's got this modifier in front which is called expect. And what is this saying? What this is saying is that my common code can use this platform object, and it can expect that it will be there. However, the implementation is going to vary based on the target platform. So next to this expect, you have this little A, and if you hit Alt-Enter, what you see is go to declarations. And you see that I have 3 declarations because in this project, in my multi-platform project, which is what MPP stands for, I have JVM main, JS main, and macOS. And if I were to click on JVM main, you see that it returns, I've got an object now with the prefix actual. So this means that it's an actual implementation of that property name and that object. If I were to navigate back and go to macOS, you can see that this says native. Right? And from the actual, of course, I can always go back to the expect. What happens if I go to, for example, the JavaScript one and comment this out? If we come back, you see that it also already gives me a red. Yeah? Because it's saying expected object platform has no actual declaration in module JS main. Okay? So this means that it's doing the compile time check for you, making sure that you're not deploying to a platform where you don't have a specific implementation. Right? So let's put that back. And we get it all run. So this now allows me to essentially create these multi-platform projects where I can share as much common code as I have, and then from there, just delegate to the last platform. How many of you have heard of a podcast that I do called Talking Kotlin? Sorry, just let's do this again. How many of you have heard of it? Okay. I really need to get a better person in marketing. Right, so I do a podcast called Talking Kotlin. Now, how many of you have heard of it? Still the same people? I just said it. In the last episode, I've been doing, I mean, fair enough, I haven't been doing this for long, only 2 years. But in the last episode, I interviewed Mark, who's a chap that works at Pivotal, and in it, he talks about using multi-platform and using common code and pushing it to the extreme. Now, he's using it for game development. So essentially, the only thing that he was implementing on each platform was the pixel drawing. Everything else he managed to essentially abstract away to common code. Now, granted that you probably are not going to have the same scenario for large line of business applications or for small line of business applications because you don't want to draw the pixels, on the platform. You want to use UI elements, etc. So there's going to be a different level of code that you're going to interact with. But the point is that if you think about your application, the majority of the logic, validation, all of this can be common code. You don't need to repeat this process over and over again. So you get the best of both worlds. And as a bonus, you get to know about my podcast. Okay. Now, the other thing that I mentioned is scripting. Now, scripting is very similar to Kotlin, source code file, with the only difference that we don't actually have to worry about having a main block or anything like that. So, if I do b.kts, right, that will create a script file. Can anybody tell me what the S stands for? Script? No, it doesn't actually. Yeah, of course it does. So here, I can just say print line, this is a script. Print line, and another one. And you can essentially execute any kind of code you want. To run this, I just use Kotlin C. Anybody ever use Kotlin C? It's the Kotlin compiler. C stands for compiler. And if you execute it without a source code, it gives you a REPL. So you can do 2 + 2, and it says to you 4. And you can quit. And in fact, you get the REPL inside IntelliJ as well in a much nicer way, which is with syntax highlighting, completion, and also a whole bunch of other functionality. Okay? So you can use it inside the IDE as well. And sometimes it works. Now, to run this as a script, I can just do Kotlin C script, and then it's called b.kts. And essentially what this is going to do is invoke it as a script. It's not going to compile it or anything, it just basically invokes it as a script. Now this is nice, but again, what can I do with this? There isn't that much that you can do. Actually, you can. There's quite a lot you can do with scripts. In fact, Someone from the community, Cedric, who worked on TestNG, or actually created TestNG, has created a new thing called Cash, K-A-S-H, which is a bash script in Kotlin. They're still using the K. Okay? But you can also take this to the next level, right? So for instance, if I go to Documents, Presentations, let's go to Native, anywhere, Scripting, you can see that I want to be able to leverage, because this is running on the JVM, the scripting, why can't I leverage what's on the JVM? It would be cool, right? Because if I can't do that, if I can't bring in a dependency or anything like that, it severely limits what I can do. You can actually do that. If we take a look at, let's do a v HTML main.kts, you can see that here I'm actually importing dependencies from Gradle. And I have this annotation at the top, which is file repository jcenter bintray.com, file depends on, and then the actual Maven dependency. So I can make use of things that exist on the JVM. Now that repository and depends on is extremely flexible, because that isn't built in to the scripting. That is actually your own definition of scripting. So if you know Gradle, of course you all do. Gradle now works with Kotlin. They have their own definition for scripting. We have a default definition, which we ship with the compiler, and it has things like repository depends on, etc. But you can pass in your own definitions for scripting. So you can essentially create your own extensions to scripting and then pass these in and host them, etc. And talking about hosting, if we open up our application, open recent, scripting, here you can see that I have a script file, and then I have a script host. So the command line that we just saw with the scripting essentially is doing this. It's launching your basic JVM scripting host, and then I'm passing my KTS file to it and executing that. So if I were to run this application, it's going to load up the script host, get access to that source code file, and then just execute it. Okay? Now what I'm doing here is result eval script sample.kts, print the result, and then here I'll showing the actual execution of the code. So you see add code anywhere, then the loop up to 100, and then I'm outputting the result. So this means that I have information on how the script was executed. So if we go back to my script file and I add an error, for instance, here, and then run this one more time, you see that this time it's not going to output the result, and it's just going to output failure. And then the failure is going to tell me severity, the location, the line, column, absolute positioning, etc. Now, what does this open up for you? It opens up quite a bit, because now what I can do is combine some of the cool features that Kotlin has for creating DSLs, combine that with the actual scripting, or even if I don't want to combine it with the scripting, use this to define my business rules or what have you, and then just have it as a script file and provide the hosting or what have you. Okay. How many of you have played with DSLs with Kotlin? Right. So there's a session today that will dive in deeper into how you can do that, leverage that. I'll give you a little small taster of how that works, because Kotlin DSLs are probably one of the most undervalued things in the language. They're very, very easy to create DSLs. Everyone familiar with the concept of a DSL? So DSL stands for domain-specific language, which is a language that is specific to a particular domain. And I even sound smart. It's like I just use the same words to do that. So let me show you quickly what I mean by this. Let's go ahead and create a quick application. Create new project. JVM. Next. Next. Okay, so not script. We're going to create Kotlin. Why is this not? Oh, dear me. Gradle. Create new. Let's just do Gradle JVM. There we go. I know. Naming is hard. So here, I'm going to wait for Gradle. There you go. And now we're going to create a new file, Kotlin file, ABC. Okay. So main application point. And then let's go ahead and do something like, for instance, a flight or a car trip. So I can say, for example, car trip, and then I'll do start at the Conrad, end at the, I don't know, airport. ETA, this is Bengaluru traffic, so about 12 hours. Type, and then we'll say, for instance, four-seater or four-people-seater equals true. Okay? Four-people-seater equals true. Now what I'm going to quickly do is give you a glimpse of this. I won't dive into too much details. If you're more interested, you can go to the session. But I'm going to do DDD now. DDD is otherwise known as DSL-driven design. So it's all red, and then it's going to become not red. Okay? So for this to not become red, you go to Fonts, Settings, and you... Actually, this is very easy. You don't even need to know Kotlin. All you need to do is just press Alt-Enter. So I create an Alt-Enter, I create a function. Yeah. I create Alt-Enter, I create a function. Now I know that's a function. If you look at the top, car trip, curly braces, what does that look like? A higher order function, right? Yeah. So I know that the parameter here needs to be a higher order function. What should that parameter be? Well, I could pass in a property that has these, pass in a class that has these properties. So let's try and start doing that. So I'll say, for example, car trip, and then var start at string equals empty, var end at string equals empty, and then var eta string equals empty, and then type is car type, and then this one is going to be car type empty. Okay? And now I'll do class car type, and var four seater, what did I call that? Four people seater. You really should come up with shorter names, Hadi. String equals empty. Okay? What's wrong? It's a Boolean. It's a Boolean. Well done. I was just making sure you're paying attention. Well done. Okay. So now, what can I do? Now this becomes a lambda. So I could come and say car trip, and then do x, and then put in an x here, and that looks good, right? No, it doesn't. In Kotlin, remember, if there's only a single lambda, you could just put it. Oh, did I delete a line? So let's go ahead and delete this one, and then I could do that. But that's not what I wanted either, because that kind of sucks, right? It's got that it. Now, I'm sure you all know about extension functions in Kotlin. If not, we'll dive deeper into them later on. But one thing that an extension function is a function. A higher order function is a function that takes another function. What if we combine those two things? We can. It's called a lambda with receiver. So instead of passing an extension function, instead of passing a function, I could just pass an extension function, which is represented with the name of the function, and then a dot, and voila, suddenly that works. Yeah? And I could do the exact same thing here, except I can't because type isn't really a function. And this isn't correct. Type isn't, let's call this car type so I don't get this. Car type isn't really a function. Did I just do manual refactoring? It's not a function, it's an instance. It's an instance, it's an object. Can I invoke an object in Kotlin? Of course you can. You create a member function. What am I doing here? I have car type, create function, no. I'm missing the car type constructor. Oh, var. I'm like, why is this? Sorry. Okay, so Alt Enter, create member function on car type invoke, right? So if you create an operator in a class called invoke, then you can invoke that object. And in this case, what do I want the parameter to be? Exactly the same as the previous pattern, which is the actual car type. Yes? So here I would say car type extension, and now this suddenly works as well. Okay? You see how easy it is to actually create DSLs with Kotlin. And you can create these DSLs to leverage different parts of your applications. People often say DSLs is not, I have to create an HTML DSL. No, don't do that, because first of all, we've already done it. Second of all, if you ever want to improve on it, create one for Markdown, because Markdown is generally better than HTML. But you can use DSLs for scripting, for business rules, for configurations. There's already libraries out there that use Kotlin and DSLs for Terraform configurations, for all of the different cloud providers, etc. Now, I haven't gotten into how you actually implement this, because that will probably come in the session that's later on dedicated to DSLs. And I've somewhat cheated over here, because I've done mutable types, mutable properties, and initialize them. You generally don't want to do that. You want to stay away from that. So the solution here would be, for instance, to create immutable properties and then create a type builder using the builder pattern that then generates a car type, and then have the extension of that instead of the actual data class itself. But the point here I really want you to walk away with is that Kotlin targets multiple platforms, but you also need to leverage the language. And Kotlin DSL isn't a platform, but it's something that could be used pretty much anywhere in your application. Okay? So with that, we're basically done. As I mentioned, the rest of today, you got a glimpse of everything that's possible, and then we've tried to provide you with enough sessions on all different platforms that you can dive into deeper and see how things work under the covers on all of these different types of applications and platforms you want to target. With that, we're over. Thank you very much.